Hey everybody, so let's proceed with our Python tutorials here and learn how to create and manage and use what we call collections or very basic what we call data structures. In Python, there are several types, and I'm going to cover the ones that will be most relevant as we proceed with this course on data analytics to us. The two basic structures that we're going to cover are lists and dictionaries. So let's start with the list here. What I want to begin is by going straight to an IPy notebook, and I've got a reminder here of the basic data types we learned a little while ago: integers, floats, strings, booleans. So we're going to create a list object, which is going to be a collection is basically more than one variable. So multiple variables of the same or different types. So the most basic type of collection is a list. Let's make an empty data list. So the way we create a list is with the square brackets. We can still use any same naming conventions as we use for variables like these up here. Here, data list is empty. There's nothing inside of it. So let's go on and create now a list with something in it. So here in this name list, we're going to create strings. So I'm going to do that. Let's add in the rest of our strings. So this is our name list. All right. So Python knows that it's a list because I use the square brackets. Also, if you're familiar with programming in the past, you'll notice that we didn't have to, this isn't like an array list, or it's a mutable list where I can put in any number of items I want to in the list at once without declaring ahead of time exactly how many items are going to go in there. It's mutable, which means that we can edit this list. So, or all lists are mutable, meaning we can edit them. So immutable objects can't be edited. So the immutable version of a list in Python is a tuple. So a tuple is just like a list, but we won't use those right now. Anyway, let's go ahead and process this and store the name list in memory. Before we move on and learn how to edit and update and delete and mess with lists here, let's add a few more lists that we can use. So we've got let's have a list of strings, and notice that when I use strings in a list, this isn't like English writing, I don't put my comma inside the quote. So we're used to that in our English writing class, making sure the commas go before the quote. Not so in programming here. We separate items in a list with a comma, whether it's a string or a number. So now let's make a number list. We'll say this is the age of everybody. And let's put in, I have no idea, I'm just going to guess here, 38, 38. I think they were in the same grade in some episode of Simpsons. 8, and we'll say 1. All right. So just like with variables, either single or double quotes around strings, none around numbers. This is now a list of integers because there's no decimals. Let's make a float list, like height. We'll just guess that here. Equals, I have no idea, 5.9 feet, 5.2, 4.1, whoops, 0.1, 3.9. No. Bart's got to be a little taller. I don't know, 4.1. Lisa 3.9. Maggie will say 2.0. All right, so there's our float list. We can do Boolean list. So we'll say it's the episode where they went and rode, what's that roller coaster? The Tooth Chipper. Yes, I forget which episode it was. Tall enough to ride the roller coaster. We're going to put true, 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 false, false. Looks like the cutoff's barely between Bart and Lisa here. Okay, so we can also have lists of different types of objects. So I'm going to make some mixed lists here and put all these together. I'm going to pause the video so you don't have to watch me create all this. All right, I added a bit of documentation here too. Here's our empty list, strings, integers, floats, booleans, and our mixed lists. So here I formatted them as records or a case. This is kind of like a row in a database or a spreadsheet or something like that. Finally, let's create a list. We'll call it list of lists. So this is what you'd think of by putting all those together in a single data list. let's say that equals, and the way I'm going to do this is simply copy each one of those inside this list with a comma separating them. So notice the first element in this list is a list itself. Second element is a list, and so forth. Go ahead and add all of those in there. Okay. So if you can create a list of lists, then can you create a list of lists? Yes, you can. You can go as many dimensions deep. Well, I don't know. Maybe there is a limit at some point, but I've never run into it. But lists of lists are common. We use these to hold what really this is basically a record or a table. So each one of these, think of it as a row, and this is a second row, third row, fourth row down a table. And then a column, we have names as a column, ages as a column, height, and tall enough to ride. So another way to create a list like this, since we already had the data stored in those prior lists, we could have done something like this. We could have said data list equals, we could just say record one list, record two list. Because those objects were created right up here, I can just refer to them down here by name, and it would have the exact same output. All right, record 5 list. All right, so let's go ahead and run that, and let's print out data list. See what we've got. Okay, see how it prints it out here. It recognizes, oh, you've got a list of lists. Let's put the items down there. Is that how it prints out other lists? Well, let's find out. Let's try just record one list and see what it prints out. Nope, here it prints out with everything in the list on one line. But in this case, the printer just recognized that we've got lists of lists. Let's put them on separate lines. All right, cool. So next, let's talk about reading from lists and selecting items out of a list. So the way we refer to a list, you noticed right here, I just mentioned the name and it prints out the entire thing. What if I just want the first record out of data list? Well, that's when I use data list. And we always use square brackets, and we refer to the items in a list by their index location. Index location refers to its position in the list. So rather than print out data list, let's go back to name list here. And I am going to, first of all, let me print out the whole name list so we can see what that looks like. All right, there they are. Now let's extend that and print out just Marge, how about? So you look at Marge and think, okay, she's in the second position. All right, well, bracket, let's put the number 2. And instead of Marge, it prints out Bart. Okay, if you're familiar with programming, you know why. That's because collections have zero-based indexes or indices. What that means is Homer is not number 1, Homer's number 0. Marge is 1, Bart's 2, Lisa's 3, Maggie's 4. So if we want to print out Marge, we put in 1, you get her, and then so just so you can see 0, yeah, that's Homer. So we referred to objects in lists based on their index location, and that's zero-based. All right, next, let's refer to something in the data list. What if we want to print out Bart's height from the data list? So when you have a list of lists, you refer to the first index location with the first set of brackets, second with the second set of brackets. So look right back up here at data list. So this first set of brackets is going to refer to which of these lists we're referring to. And so if we want Bart's height, that's going to be 0, 1, 2, 2 for Bart. And then the second one says, okay, that object in position index 2 of data list is also itself a list. So to pull out one item of it, we're going to refer to that by index. So his height is 0, 1, 2. So we put 2 there, and that's what's going to give us 4.1. All right, so reading items from lists and lists of lists. Next, what if we want a range? So let's say I want to print out, I don't know, the first 2 names in the name list. So we go to name list, and we can refer to a range by the beginning and ending of the range. Actually, no, sorry, I misspoke. The beginning, this is where the index begins. So we want to start at Homer. And this one is not the ending range, it's the number of items after that index that we want. So if I put 1 here, it's just going to print out Homer because I'm starting at Homer and I'm only printing out one name. So if I print 2, start at Homer, print out that one plus one other for a total of 2 items. In Python, you can also shorten that. If you don't put in the 0, just put in a 2 like that, it's just going to assume that you meant to start at the beginning. So oftentimes you'll see code like this where they've just omitted the 0. Just know that that implies that there's a 0 right there. All right, let me show you one other cool thing here. Let's do name list and -3. What does that do? It says start in the back and go 3 in. All right, makes sense. Maggie, Lisa, Bart. That's our third from the end of the list. I can actually extend that a bit more and say 3 colon, and that'll give me everything starting 3 back to the end of the list. So a range. That'll come in handy at times. All right, so these are all of our different ways of accessing items out of the list by index number, either by an individual number in a list of lists, in a range, and from the back of the list. Now let's extend that by pulling an item out of the list and storing it into another variable. So let's make a variable called dad and set it equal to namelist 0. So whenever there's an equal sign, this becomes an assignment statement. So nothing's printed out. All we're doing is setting the value of dad equal to the value in the position 0 of that list. So if we're to print dad out immediately after, we then get Homer. Now, notice it puts the quotes around it because it recognizes it's a string. Now, I want to show you a shorthand notation to set several variables at once. And this is often used in data analytics tasks when we're calling stats functions that return several things, like an effect size and a probability and an error or a variety of things. So we can actually convert, let's do the, I guess we can do the whole name list. Dad, mom, brother, sister, baby, equals, and I'm just going to set it equal to name list. Name list has 5 values in it already. So as I run that, and then I can print out brother, for example, it got set to Bart. So it'll take any object that returns 5 or more values and set the values of that list to, or at least the first, up to the first 5 equal to these names. So for example, I could still do the same thing and just say dad, mom equals name list. And I can print out mom. And it's simply going to, okay, there we go, perfect. Too many values to unpack. It says, yeah, this thing returned 5. You only took the first 2. We got a problem there. So there are other packages where it will just automatically take the first 2 values in the list and set them equal to these variables. But I forgot, it looks like with native Python lists, you can't do that. You've either got to have the exact number or not, or you just refer to them by index. So I think we probably could, though, say start at 0 and go to 2. There we go. And it works that way if we just shorten that down to the first 2 items in the list. Okay, accessing, reading, setting equal to variables. Let's move on. And let's do this with, let's add items to a list. We haven't done that yet, I think. Or add items in a list. So let's simply update something. So let's say up here in our original list, right here, height list, we've got Lisa's height wrong. Let's say she's a little bit shorter. She's 2 years younger than Bart, so she's actually 3.7, or I don't know, something like that. Or no, maybe Bart's too short. Let's just update Bart and say height list. And let's reference Bart's height, which is at position 2, equals 4.15 instead of 4.1. So now, what happens? Does it change all of them to floats because that one's now a float? Here we go. Nope. Simply updates one of them because you can have lists of multiple data types. So naturally, you can likely have lists with some variables have more or fewer decimal places for floats. So you just simply reference the item, but instead of simply saying height list 2 to return that value, you then equal something to update the value. Same thing with a nested list. We'll call this data list, and let's reference. Let's see, Bart is the 3rd one, I think, and then of Bart's list, which is right here, height is the number 2 position, 0, 1, 2 in. So, oops, there we go. 2nd position in equals, whoops, equals 4.15. So now data list should also be updated. There we go, 4.15 in the big one. All right, so there's updating values. Let's add and insert and what the difference is between those two. Let's do this with our name list. And let's add, or we call that append, using the append method of the Python list object. And sorry, append because it's a method. We don't use square brackets. Methods use parentheses. Square brackets are used to refer to indexes. So here, because it's a method, we're adding something or doing something, it's going to be parentheses, which means we're going to add in, how about Millhouse? I think that's how you spell it. Oh, but can't forget quotes because it's a string. All right, let's do that, and then let's take a look and see if it got appended. Perfect, there it is at the end of the list. Let's insert instead to put, learn how to put an item in a particular place in the list. So we forgot to add Millhouse's parent, so we're going to use insert. And let's see here. We start by putting the position, the index position, and then the object to be inserted. So the position, if we put Millhouse's parents in, let's put in Luann first. And then, oh, sorry, her position is going to be 0, 1, 2, 3, 4. We want her in front of Millhouse, so we'll put her in position 5. And then let's go ahead and insert Kirk. Luann definitely is in charge. We're going to make Kirk 6. All right, there we go. Oh, maybe if I... there we go. So here's our name list. And, oh, I ran it, and then I ran it again. I ran it once, and I forgot to print this out, and so it put in Luann and Kirk. And then, because I ran the cell a second time, it added in again. So we're going to rerun name list right here. And it recreates that object again. Then we'll come down here and insert Millhouse, insert parents. There they are. Homer, Marge, Bart, Lisa, Maggie, Luann, Kirk, Millhouse. Cool. All right, that's adding and inserting. We use append to put it at the end, insert to put it in a specific location. Now let's go through and remove items from a list. This one's pretty, there's two methods to do this, used in different situations. Let's first, let's remove name list dot remove, and remove allows us to remove by name. So we'll start by removing Kirk, and then print out. Now let's go ahead and remove all of them. So with remove, notice that it doesn't matter what position it's in. It's going to find it and remove it. Oh, I spelled Millhouse wrong. And now it's going to give me an error on the first two. See how these two ran fine? It was this one that I'd spelled wrong. Now it's going to give me an error again because Kirk and Luann are no longer in there. So I'm just going to comment those out this time. There we go. Millhouse removed. There's the full list. I'll get rid of those so we can remember what we did. All right, let's use the pop method now instead. So pop is something that we use. It removes an item but returns the item. Let me show you what I mean here. I'm going to bring our name list back in here and reset it each time. Give me that one again. And this time I want to say name list.pop. And let's do that with pop. We use, pop we'll use with an index. Let me show you here. Oops, didn't mean to do that. Hold on. All right. Oh, I keep forgetting that. All right, when I use pop, it goes straight to the last one on the list. It returns it, and now notice what happens when I print out name list. Millhouse is gone. So by default, pop removes the last one. However, we can also refer to a specific index. So let's let's name list pop, and let's get rid of number 5 would be Luann, number 6 is Kirk, and then name list printout. So it should print out 3 things actually. Oh, 6 is gone, because once we remove number 5, that means that Kirk is now number 5. So I actually just end up running it twice, or I could run it in reverse, or I can also pop by, I think I can use the name as well, but no, that's all right. I'm just going to comment that one out. There we go. So, oh, I didn't print this out. So pop returns the value in the 5th position as well, kind of like we did right here where it returns it back. I just, because I had this here, it overwrote Luann and Kirk that were previously popped right there. And then finally, you can use namelist.clear if you want to get rid of everything, to start with a new list. We often do this when we've got to use a list as part of some nested loop, which you'll learn about later in the course. So there's our cleared out name list. All right, let's go over just a few of the relevant functions and methods that we use with lists. I'm just going to copy these in and show them to you to be quick about this part here, though. These can be pretty useful. So let's rerun name list again in all of our lists and start fresh by running that cell. And then we'll come down here and take a look at what all of these do. All right, so len, as you can probably guess, length, number of items in the list, and data list. Now remember, data list was our nested list. And you might look, here's our data list right here. You might look at that and say, well, wait a minute, there's a lot more than 5 items. It's actually 5 times 4, 20 items. Well, we're referring right here to data list, which is the outer list. Even though that each list item is a list of is a list itself, it's not going to go in and count each of those items. Now, I think if I went data list and no, that wouldn't work. I could do data list and I could say, give me the length of that list of lists. And now that tells me my data list is 4 because the index 2 position has a list inside of a 4. But anyway, that's how that works. So length is number of items. Max, as you can guess, this is the max age. However, pretty sure the max age isn't 328. Did I mistype up here in age list? I sure did. There it is. Let's fix that. There we go, 38. And now run this again. There we go, max 38. Min to age list count for 38. Oh, this is count the number of times this value appears. So since both Homer and Marge are 38, I get a 2 down here. Down here under index, this tells me what's the position of the value of 8. So here, if we look up here at age, in the age list, 8 is in the 0, 1, 2, 3 index position. There's times when it's useful to find out what the index or location is of a certain value. That's what this one does. Namelist.sort, regardless of what items are in there, sort them alphabetically, and then of course reverse sort. All right, that's it for Python lists. We'll move on after this one to dictionaries.